Okay, look at example 4. Notice the rule here, or the problem here. It says simplify again. Here's that word simplify again. This says simplify by adding like terms. Okay, look at the difference in the problem from this one to the last one. What's happening here is everything's being multiplied. It's just one term, everything's being multiplied. Here, I've got one term being added to a second term, being subtracted to a third term, being added to a fourth term. Okay, there's 4 terms in this one. To simplify by adding like terms means I need to find like terms. And what we've so far seen with like terms is they had to have the same letters, right? So far, that's all that really mattered. If the letters were the same, they were like terms. 5x and 6x, like terms. 2xy and 7xy, like terms. 7xyz, 2z, not like terms. xyzz, not the same. All right? Same letters. But we also have to have the same powers on the same letters. So if x is to the second power, x has to be to the second power. If y is to the third power, y has to be to the third power. The only other thing that's going to happen is going to be same location. That's when they start getting to be fraction looking. We're not going to do those today. So let's just worry about these first 2 criteria for like terms. So let's look at our terms. First of all, let's look at the same letter. All right? MXYP, 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 MXYP. All 4 of these terms contain the letters M, X, Y, and P, right? Check. So as of right now, based on that first criteria, they're like terms. Second criteria has to be met also. All the M's have to be the same power. Let's start with M. M cubed, M cubed, M cubed, M cubed. Good. Moving on to X. X to the first, X to the first, X to the first, X to the second. Different. That one's different from the other 3 because this X has the wrong power on it, okay? These 3 still have all the same powers, right? M and X. Next one's Y. Y squared, Y squared, Y squared. P to the first, P to the first, P to the first. Those 3 guys are like terms. This is not a like term because, again, X to the first, X to the first, X to the first, X squared. As soon as one letter doesn't match up, it doesn't matter about the rest of them. The Y didn't match up either. This Y is to the first, those Y's are squared. But again, only one letter out of sync doesn't count. So, to get the answer, I simply perform math on the numbers. 2 plus 3 minus 10 makes what?
-5.
-5. Very good. 2 and 3, +5, minus 10 makes -5. Subtraction because the signs are different. Negative because 10 is bigger. What made them the same was the sequence of M cubed, P to the first, X, Y squared. Again, I like alphabetical order. That's how my paper would look. Any sequence of letters having those same powers on each letter would be fine. If you wanted to go with this one, M cubed, X, Y squared, P, fine. P, X, Y squared, M cubed, fine. X, Y squared, M cubed, P. As long as it's those 4 letters to those powers, it doesn't matter what order they're in. This other term that's not a like term is still part of the answer. Again, I like alphabetical order, so M cubed, P to the first, X squared, Y. There's no number in front of it. What number would be in front of it?
1.
There's a 1 in front of it. For the sake of working a problem out, I like to have that 1 in front. For the sake of a final answer, I like to leave it off. So for me, I would probably leave it off. Put the 1 there, it's not wrong. It's just not necessary. That's the most you can possibly do to this problem. Okay, let me say some words right now that are going to need to stick in your head because every year I've got algebra students breaking this rule because they didn't listen to what I say right now. You cannot add unlike terms. Okay, so once you made this decision, like terms or not, this guy and this guy are unlike, right? Because x's and y's don't match up for powers, right? Addition or subtraction of unlike terms is illegal. You cannot do it ever. There's no rule in math that allows you to ever make this any simpler than this. That's the best answer you can possibly get out of this problem. And you're going to continue to get problems where the answers get bigger and bigger and bigger and bigger. It's going to make you feel kind of sick to your stomach occasionally when you see some of these really big answers. There's no way in the world that can be the right answer. Probably is. Because you cannot add unlike terms. So a lot of times you leave answers looking like this. That's the best you can do to it. Don't try and make up rules to make things look prettier. Sometimes the ugly answer is the right answer. So be careful that you don't make up your own rules to stuff.